There we go. All right, ladies and gents, let us take our attendance. Landon, Tommy, Boy, Andrew, Keegan, Owen, Dylan, Josh, Cole, Nathan, Nick, Caden, Taylor, Aiden, Jake, Matthew, Brady. Matthew, why does it say you're not here? I know, it just my computer says you're not here. Yeah, super awesome. Have you ever mixed oil, water, and soap? Have you really?
I don't think it was like
Do you know what soap does? It mixes them together, right? Because it has a long carbon chain, and then it has a very carboxylic group at the end, COOH. It's pretty cool. So it has a polar, non-polar. Pretty cool. All right, real quick, what I'm going to be doing, I'm going to pass back. I got papers. Not a fun story. I don't want to pass back papers. After a little while, it starts to stack up, and then it's just like, then I just got to do it. You know what I'm saying? All right. Matthew. Go. Matthew. Landon. So, Josh. Brady. Oh, all right. So, just go over that real quick. Yes, sir. Based on how you feel it. Right. So, what the feel? Yeah. All right. I think what I was first to do, big one was units. I really wanted this. Number 6 had you per meters miles per hour. That was another big one that. Two sources of air. Another one that was tricky. A lot of people said sig figs that can cause air. I accepted it. It's like grounding. Okay. It was a big one, right? You might have to stop. Only one person that the air is. Right? We're not in true free fall. Right? Then on the back, you guys need So there's ways to solve number. I'm going to show you an easier way. Using your knowledge of physics. That's 10 on yours? Yeah.
What's on yours?
It's number 12 on mine.
What two questions do you have that we don't?
I don't know.
Two missing problems.
All right. Now I'm just going to show you the second way, which is the easiest way. So it says, how high did Kobe jump? Right? There's his height. Now I'm going to start from there. I'm going to start from there. That's all I'm worried about. I'm worried about that right there. All right. So if I know what's his initial velocity right there, 0. He's at the point. All right. Let's see. What's his gravity? All right. And the time. Right? I think what the total time. The total time in this class. 0.9. So the total time was 0.9. What would be the time for 0.5, right? But then you just plug it in your delta x equal to velocity initial time a e half t. Okay. But your initial velocity is 0, so you can get rid of that part. So all you did was half of acceleration times 0.45. That's the easiest way to solve that. Yeah.
I just made it a quadrant.
Yeah, you could do that. Kind of makes sense. Fair enough. All right. All right. So what we're going to do today, we're going to finish the graph. We're going to finish those up. Don't got a whole lot left. The graphs are pretty easy. Once you figure out one equation you're going to be using the entire time, they're very straightforward. We're not going to do all of them. Then at the end of class, I'll let you work on your homework. All right. Homework is due tomorrow. We also have the test, which kind of encompasses. We just took a quiz over half of it, right? We know half of it pretty well. The other half was the speed velocity, right? Speed, distance over time, velocity, displacement. And then there's some of the graphs. You should dominate the graphs, yes. Yeah. Are you done? Well, then you guys are golden. Actually, I might have said today. I did say Monday.
No, you said on Zoom, I said Monday, then moved it back.
I really have no idea. I remember.
I don't know. I don't know. I'm very intrigued. Yes. Question on quiz. What is number 2? Is that the car, the acceleration? The answer is 4 meters per second squared. I don't know what number that is, or letter. We'll go over that at the end. I'll show you. All right. So let's see, where were we? Let me present my screen. That is. All right, oh, that's not you guys. There we go. There we go. Pure substances. Ah, okay, okay. So Let me slide that over. Pull up my image mate. How do other teachers go about their business? Smart boards. That is clever because you can record the entire board.
More you can like write on the board itself.
Right.
So like this isn't even, so it's a little weird.
But still, they can record their board and everything they write on a smart board. Yeah.
I believe we could do that.
Camera on the board. So it's the video while she does it. She has a smartphone as well, so they keep it right. And then she gets her upstairs, asking them out. I think that's how she does it.
All right.
Ask her.
There we go. All right, let's pull this down. Oh, whoa. I almost forgot.
Oh, I know the answer. Is the ring?
Oh.
It is a ring.
Alright.
Ow. I put them on an easy spot for Monday.
I see it, yeah.
Wow, when I say easy, you guys like zone in. All right. So we on, let me see. I went too far. This one? Nope, this one?
Last one, one before that, yeah.
One before that? All right.
I think you were just got explained.
Now, this is a lot, all right? I'm actually going to go to the next slide because it kind of explains the different forms of what each graph looks like, all right? I'm going to keep this presented, all right? So a positive direction, speeding up. And we're going to start with position time. So positive direction, speeding up. Looks like that. Okay? You kind of look, you see it, it's not a constant speed, right? It's not constant, it's speeding up, it's accelerating. Does that make sense? Which means your velocity is going to be increasing. Your velocity is increasing at a constant rate. Straight line. In the top direction, going up, right? Now, when you're constantly in constant velocity, what's your acceleration line going to be like? Very good. Straight across. It's going to have a slope of 0. But in this case, it's going to be positive, right? It's going to be above. We have a positive acceleration. Okay. Oh, next one, a little tricky. Negative direction, speeding up. Right? Negative direction, but speeding up. So it's curved. You're going negatively, right? You're going down. Negative is down. And you're speeding up. So it's going to get faster. It's going down. That kind of makes just a negative slope, right? Which means on a velocity time graph, constant velocity going down. All right, so I have constant velocity. What's that mean for my acceleration line going to be? Same thing, flat, but below the line. It's going to be the, there we go, flat, but below the line. Very good. Am I going too fast? We good? Sweet. All right, positive direction, slow down. Ooh, okay, so I'm going positively, but now I'm starting to curve up. I'm starting to slow down, slow down, slow down. All right. All right. So that's slowing down. Ooh, all right. Velocity, positive, slowing down, right? Until you reach 0, and you'll be stopped. Now, what would happen if I go past this line? I would be going right? And now, straight line going down. What's the acceleration? Could be flat again. Negative, because it's going down, negative acceleration. Say what? These two? You're looking at the slope. So, what the things you're focusing on is your initial velocity, your final velocity, and the time it took. So if you look, the initial velocity, the final velocity, it's the same. The time it took is the same, like when you calculate it out. So the acceleration would be the same. It'll make a lot more sense on the next slide. Yes.
So is acceleration really like a one-dimensional constant? Actually, I guess.
Yeah.
It's graph
For right now.
and we get the 2D graphs.
We'll like start adding different arrays, line segments. 2D we're not gonna, it's gonna be like a week-long chapter. Very quick.
Maybe 3-dimensional graph.
Maybe in June. Maybe like after you guys take, or whoever, if you are, maybe after the test, you got nothing to do, we'll do 3D. That would be fun.
I mean, just
We could do that. All right, negative direction. Okay, negative direction. I'm going to be going, oh man, I'm going down, but as you can see, I'm slowing down. So I'm going negatively, but slowing down. Okay, which means my velocity is actually in the negative direction, but I'm slowing down closer to 0. All right, I'm slowing down, getting closer to 0. My goal is 0. That one's a little tricky to understand. All right, but if I look, where's my acceleration going to be? Right, this I'm going up. This has a positive slope. So my acceleration is going to be positive. Yeah.
So what would the
One more time.
So positive is above the x-axis, negative is below the x-axis.
Right.
So what is to the left of the y-axis?
Yeah, it would be past. It would be past. Yeah. We would be able to make predictions, but yeah, like there's nothing. This is just our starting point. All right, last one, turn it around. All right. Never do that until right this second. Yeah, I'm not serious. I never. All right, so turning around. All right, so I start going up, going up, going up. Then I come to a stop, and then I start coming back, right? All right. So my velocity time graph is actually going to look a little bit of positive, a little bit of negative, right? A little bit positive, come to a stop, and then I go in the negative direction. Oh, hold on. Wait, if I have a little bit of positive, a little bit of negative, what's my acceleration going to be? 0. Boom, right on the line, it's 0. Right on the line. Acceleration 0. That was genius. All right. Now, this is all going to make a lot of sense on this next slide, hopefully. I'm like 89% sure it's going to make a lot of sense on this next slide. I believe in you guys. All right, we're actually going to skip this slide. You don't have to match mine. We're just going to skip that. All right. And I'm actually going to skip this one for now. I want to get to the real good stuff. Number 36 is the good stuff. All right, so it's on the back. All right, this is where I'm 96% sure it's going to like be, you know what I'm saying? It's going to have the aha moment. All right. Oh, I already got the answer. All right. So there we go. Oh man, I'm struggling with technology today. Yeah, love to see it.
And then you want to press that. This one doesn't want to work. So to start like normal tabs, you just press Windows and then in the arrow key.
Learned 2 new things today. Hide button, hide button. I don't think I do, honestly. No, I want to keep YouTube autoplay. I like that. I like the YouTube autoplay. All right. So, in this graph, it says, find the acceleration of motion. Right? 36. Everybody know where I'm at? Find the acceleration of motion. Guys, let's quiet down real quick. Now, my acceleration. So, I have different equations, right? I have my three different equations. All right. Now, I'm trying to find the acceleration. I don't know what that is. It just snapped. I need to find the acceleration. Now, what do I know in my problem? Well, I'm going to look at my graph. Do I know my initial velocity? What is that? 2. I know my initial velocity is 2. Do I know my final velocity? I think that's a 40.
Wait, no. Yeah. Wait, yeah, that's after time. Did you say velocity or time? 40 seconds.
Oh my gosh.
Yeah, see, I was right. Are you good, Mr. Howard?
You okay?
This is from my day. It's where I like to hide sometimes. I think both of you.
I am sorry. I struggled there. My velocity is 10. My final velocity is 10. Now, what is my time? That is 40 seconds. Okay. So I got my data. All right. Ooh. That zooms in really far. What equation am I going to use with my data? Very first one. So I have my velocity final. So 10 is equal to my velocity initial, 2, plus acceleration, which I don't know, times time, which is 40. All right. So you subtract the 2 over, so 10 minus 2 is 8, is equal to that. You divide it by the time, divided by 40, 8 divided by, that's 1/5, so it should be 0.2 meters per second squared. Yes.
You just done the acceleration equals change in velocity or change in time.
Yep. Yeah, easily, very well. I'm using these three to show you everything you need to know about acceleration is right here. Yes.
So with this, finding the line, finding acceleration.
So the slope of this would be, yeah, you can do that. In a velocity time graph, yes. Yeah. All right. Next one says find the displacement. Okay. Well, I'm going to do my displacement equation. Delta x is equal to velocity initial times time plus half the acceleration times squared. All right. Find the displacement. Do I know my initial velocity? Yeah, that's 2. Times my time. Time is 40. Plus half the acceleration, which I just solved, is 0.2, times my time squared, which is 40 squared. Ooh, I'm going to need a calculator for that. All right, let's see. Times 0.2 times squared. I got 240 meters. Does that make sense how to solve those? All right, guys, that is the same thing for all these problems. That is the same thing. Using the graph, determine the average acceleration. Same thing. Number 38, find the acceleration. Same thing. Right? And velocity time, you calculate the slope. All right? And then the displacement, same equation. All right? 39, same thing. 40, what can we say about the speed? Wow, well, good. So I want you to try one of these. Try 37 out real fast. And that should be, that's it. That's it. Try one of these out real quick. You already done? Should be negative, let's see, acceleration. Final velocity, 50 minus 0 minus 25, negative 25 divided by 50, negative 0.5 meters per second squared. Oh. If you want to use fractions, that's fine. Sig figs don't occur with fractions.
But like that's like, but if it was like 0.26758.
Right.
Just use fractions. If you do fractions, you get out of step.
But like if you had
Essentially.
0.61956, you had to round 6 up, you have to be done.
All right. Hopefully you got negative 1/2 meters per second squared. Final velocity minus initial velocity divided by time. Does that kind of make sense?
Yeah.
It will be that same thing on 38, acceleration, displacement. It'll be the same thing. Find the acceleration, displacement. All right. I'll do one more. I'll just do a quick. I'll do A right here. I'll do A. All right. Final velocity. What's my final velocity here? For A? 30 minus initial over my time. How long did that take? 5 seconds. 30 minus 0 divided by 5. That's what? 6 meters per second squared. That's your acceleration. Yeah.
For like the displacement of each section, are you like the section itself,
This section is
or is it just added on to the previous
the
example? Number 30, would the displacement be the like that be 70 like everyone meters?
I'll show you all the answers.
Oh.
They're all your answers.
Thank you.
Interrupted. Right, Robert?
Yes. Oh, no. I like questions. I love. Post the answer key. Well, there you go. All right. That's why I really wanted to jump to this. Looking at the, is it important? Are you good on that one? Got your answers. Like looking at, oh, you know, positive stuff, negative stuff. So you know that. But looking, like comparing them, is that important? Not tomorrow. Like tomorrow, I want you guys to know how to calculate acceleration. I want you to know our entire chapter, Unit 1, everything from September 8th to October 12th. But if you look at the AP exam percentages, this chapter says like it's 16 to 18% of the test.
Whoa, that's kind of
Huge.
Because acceleration is
Now, the next chapter, 2D kinematics, is only like 5 to 6% of the test.
But you said it's a week long.
Yeah, that's why I'm only studying them.
Well, it's a week long.
I mean, how many weeks of school?
You'll see, there's like, really? We're going to do 2 labs in chapter 3. That's 2D. Two labs in chapter 3. 5, 2 days of notes. 1 homework a day, probably. And we're probably not going to take it. So. On Thursday, 5 day. Maybe even Friday. We have we do have about 10 minutes left. I was going to answer any questions you have. Or homework. You guys have any homework? Yeah. Yeah.
Do you use our name? No, it's just a coincidence.
That's part of
Wait, what's the question say? Because mine's different. What's the question say? Mine's different than yours. Yeah, number. Okay. Here we go. Keegan runs the speed. All right. One. See, if I tell you how to use quadratic formula without it.
Let's go.
Oh, you said equal to.
I'll show you.
You said Keegan equal to bus.
Yes.
Yeah, guys, take this time to review, do whatever. All right, I will. So, a man runs at a speed of 4 meters per second to overtake a standing bus. When he is 6 meters behind the door, the bus moves forward and continues with a constant acceleration. All right, so here's my man, my dude, Keegan,
himself.
running after a bus. All right, the bus is 6 meters up in front of him. The wheels on the bus go round and round. All right. So Keegan, 4 meters per second. Is that good speed?
That's pretty good speed.
That's good speed? Yeah, that's good speed. All right, he runs at 4 meters per second. All right. Let's see. Runs at a speed 4 meters per second to overtake a standing bus. If he runs 4 meters per second, is he accelerating? No, he is not. So acceleration is 0 for Keegan. Let's see, my bus had initial velocity of 0, but now it's accelerating at 1.2 meters per second squared. All right. So what's that? What is, or how long does it take for him to catch the bus? Well, he's going to be running until he catches the bus, right? So displacement is the same. X is going to be equal to X. X of Keegan is going to be equal to X of the bus. Okay? So when you plug in the equation, right? Well, I should say X final. X final for Keegan. It's the same as that. So I'm going to have X initial is equal to X initial plus the velocity initial times time plus 1/2 acceleration times squared. For Keegan, X initial plus velocity initial time plus half the acceleration times squared for the bus. Because the final for Keegan was the same for the final as bus. So I place them equal to each other, right? So let's do Keegan first. My initial displacement, he's at 0, right? He's at 0. Keegan is Keegan. All right. Where's the bus initial X? 6. Keegan's initial velocity. Let's see. Initial velocity was 4 meters per second. So I know 4. What's his Keegan's acceleration? 0. Oh, that's just a big 0. I don't care about the rest of that. Equals. What was the bus's initial velocity? Oh, I don't care about any of that. Plus half the acceleration, 1.2 times the t squared. Okay, so I got 4t is equal to 6 plus 0.6 squared. All right. You're going to have to subtract that over. So really, you got 0.6 t squared minus 4t plus 6 is equal to 0. Plug it into the quadratic formula and you got your answer. Yeah. Once negative. Yep, I love it. All right, so the quadratic formula is b plus minus square root of b squared minus 4ac.
Got x equal. X equals b plus 1. This messes up the song if you don't.
So let's see, we got -4. So that turns into a positive 4, right? Just make sure I'm doing this right. Plus or minus 4 squared. -4 squared is, we're just going to plug that in. -4 times a times, well, I'll just plug it in. A times 0.6 times 6. Let's see. You do that in your head? All right. Over 1.2. Good so far? Yeah. So I got 4 minus the square root of 2.4. 2 square root and 2.279. All right, you would take the square root of that.
See, this is like how fast so there would be 2 consonants.
Yeah.
No.
I'm pretty sure you're always going to use the plus. No. You're going to use the, you're not going to use the negative. Or, well, we still get a positive. It's hard to do this in no way. Or, well, 2.6. You do get there. I will have to look that up. AB. I'll have to look that up. I got 2 positive answers. All right, have a good day. We'll see you tomorrow. All right. All right. How's it going?
It's going